Okay, so today we're going to be talking about multiplying fractions and mixed numbers. And some of you may be familiar with this from last year. Your fifth grade teachers may have started you out on multiplying fractions and mixed numbers, and it's a good thing. So this might be review for some of you. For others, it's going to be new content. So by the end of this lesson, you will be able to multiply fractions and mixed numbers and use multiplication to solve problems involving fractions and mixed numbers. So we're going to go ahead and get started. You're going to look for these symbols and make sure that you're writing down anything with a pen note beside it. If it's an example and there's a pen mark beside it, please make sure you write it down. And then your quick check problems with that green arrow, make sure you're doing those on a separate sheet of paper so that you can turn that in. So our vocab today, we have one word, and it's of. And of usually means to multiply. So I have an example here for this where you would say, let's see if I have a pen going already. And down here, and a color. So if I have something, if they ask me what is 1/2 of 4, they're really asking me to multiply 1/2 and 4. So this is what they're asking me to do. Okay, so what is 1/2 of 4? It means multiply 1/2 times 4. And we'll get into this a little more detail in a minute, but we would then have to turn this into a fraction also, right? 4/1. But we'll get into that a little bit more in a minute. So that's our only vocab word today, really, is of. Make sure that you're understanding that when we see of, we mean multiply. Oops, thought I had an arrow pointer there. Okay, so multiplying two fractions. So I have this, when we're multiplying two fractions, we have this example down here, and this is very similar to what we did yesterday in class where we did the hands-on activity. So we have 2 7s, and you can see they took a rectangle and they split it into 7 equal pieces and they shaded in 2. And then over here they have 3/5. So now you can see where they took those 7 pieces, but then they made these 5 columns and they shaded in 5 columns. And then when you overlap that, this purple is the overlap section. Okay? So we have, it's asking us to find 2 7s of 3/5. I wondered where my words went, but I must have had this animated and not realized it. So we're going to multiply the numerators, 2 times 3 to get 6. And then we'll multiply the denominators. 7 times 5 is 35. So our answer for this, 2 7s of 3/5, really means multiply, right? And then we just do top times top over bottom times bottom, and we get 6/35. But you can see that there are 6 pieces here out of the 35 pieces that we made with the 7ths and the 5ths. And that's how we get our 6/35. And remember, the reason we did that activity yesterday was so that we could make sure we understood the concept. Why is that a smaller number than either of the two that we started with when we're multiplying, right? So here's a quick check. I want you to find 3/5 times 1/4 and then find 2/9 times 5/7. I want you to go ahead and do that. Pause here, do that on a separate sheet of paper, and then when you're finished, hit play and join me on the next slide. So this is something that might be new to some of you, and some kids really, really like it, and some kids really, really don't. I'm going to encourage you to try it because it's really a time saver when we get down to it, if you can cross reduce. And so this is an interesting strategy to use. So when the numerators and denominators have a common factor, you can simplify before multiplying. So if you look at this, what we would want to do with this problem really is just multiply straight across, right? We've got top times top, so we would do 3 times 2 on the top. And then we'd have bottom times bottom, so we would have 8 times 5 on the bottom. But if you look at this, you can see clearly that we're going to be able to divide something out of it because these guys have a factor in common, right? So if I were to just multiply that straight across, I'd get 6/40. And we know that that's definitely not in simplest form because they have a common factor. And if we look at the greatest common factor between 6 and 40, we're going to discover that that greatest common factor is 2. And so we could divide a 2 out of the top and then divide a 2 out of the bottom. And we would end up with 3/20 as our answer. But I'm going to show you the shortcut, and I know a lot of you guys like shortcuts. And you don't have to do this kind of division at the end to simplify. What we can do instead, and I'm going to go ahead and write that down if you need to. Pause real quick and write that down if you need to, because I'm going to erase it and I'm going to show you what I mean by cross reduce. So we know at the end of this we've divided out a 2 to get to our simplest form. So now let's put that in the trash real quick. And now I'm going to show you what I mean by cross reduce. So when I cross reduce, I'm looking and I'm saying, okay, I'm looking at these factors that are diagonal from each other. And I'm saying, is there anything that I can take out of both of these right now that I could divide out of both of these? And the answer to that is, yeah, there's definitely a 2. So if I take this and I reduce out a 2 here, and I say, well, 2 divided by 2 is 1. So what I'm basically doing here is dividing by 2. So I have 1 now up here. And then if I do 8 divided by 2, right, that gives me 4. So now I have, and these are not equivalent fractions, you guys. I don't want you to think that 3/8 and 3/4 are equivalent fractions. That is not what we just did here. What we did was just took out a factor before we multiplied. So now we're going to go and multiply straight across, and we're going to do our 3 times 1 instead. So I have 3 times 1 here, and on the bottom I have 4 times 5. And when I multiply that out, I get 3/20. So basically what I did was I did the division part. I divided out that common factor before I multiplied. And that's a perfectly legitimate move in fractions here with math. So just keep that in mind. And in that particular problem, it wasn't a huge time saver, but there are some where it really does end up being a huge time saver for you and kind of reduces the headache mess of trying to reduce fractions to simplest forms, which is sometimes, you know, a little bit tedious. So we're going to go ahead and, if you need to finish writing that down, please do, and we're going to give you an example problem where we can try another one of those, I think. But go ahead and finish writing that down. I'm going to hit trash, so if you need to pause it, do it right now. And then we'll go on to the next slide. Okay, so we don't have an example just yet. We have another, or practice problems for that. We have another concept, and this is really important. Multiplying a whole number in a fraction. So when we go to multiply back up the truck. When we go to multiply a whole number in a fraction, we have this 9 kind of hanging out here, times 2/5. You're like, well, what do I do with this 9? Does it go with the top? Does it go with the bottom? What does it go with? So the first thing we need to do is write this whole number as a fraction, right? And so a lot of kids will kind of fret and worry about this, and really it's so simple. All you have to do is put it over 1, because we know that 9/1 is the same as 9. So we're just going to rewrite it like this, 9/1. And now I have my 2 fractions, so I can just go ahead and do top times top over bottom times bottom. And when I do that, I end up with 9 times 2 on the top, which is 18. And then I have 1 times 5 on the bottom, which is 5. Now, am I going to leave it in this form? Probably not, right? Because we're going to end up with a mixed number at this point. So do we remember how to find that mixed number? And some of you might say, oh, yeah, I remember you divide the top by the bottom and the leftover goes. And we could do it that way. But we can also think about just knowing what we know about fractions. Well, how many whole pieces do I have in here? How many 5/5 do I have? Well, I have 5/5 here. And that's one of them. And then I have another 5/5, right? Well, that's 10/5. Well, I have another one here. That's 3 whole pieces, but that's 15/5. Do I have enough to make another 5/5? I don't, but I have this 3/5, right? So I have 5, 10, 15, 16, 17, 18. So I have 3 whole pieces and 3/5 left over. And some of you might go, oh, that makes great sense. And some of you might go, well, I would rather just do 18 divided by 5, right? And I get 3. My remainder is 3, so I have 3 and 3/5. And that's okay too, if you understand it that way. I totally don't have a problem with that, but I want you to understand conceptually this is what we're doing here. We have 3 whole numbers, 5/5, 5/5, 5/5, and then the 3/5 left over. So we want to put it in a mixed number format. We don't usually want to leave it in an improper fraction where it's top heavy like that. Okay, so here's a quick check. We have a baby alligator that is 5/6 of a foot long. An adult alligator is 12 times as long as the baby. How long is the adult? So you've got a multiplication problem there. And you can see it's 12 times the baby length. So you're looking at these pieces of information, right? You've got this, which is 5/6 foot long, that's the baby. And then we know the adult is 12 times as long as the baby. 12 times the baby. So go ahead and write out your expression for that, and then do the math and let me know what you get, and we'll check it tomorrow when we come to class. So multiplying mixed numbers. So the first thing I want you to do when we come across multiplying mixed numbers is I want you to estimate an answer. And to estimate an answer, I want you to round these to a nearest whole number so that we're not looking at fractions anymore. I want to say, okay, 2 2/3, that's really close to what whole number? And I would say 2 2/3 is really close to 3. So I'm going to say 3 here. And then I look at my other one. Well, 3 1/4, what is that closest to, 3 or 4? I'm going to say, well, yeah, it's definitely closer to 3. So 3 times 3 would be my estimate. So my final answer should give me something in the ballpark of 9, okay? So I want to estimate an answer first so that when I get my answer, I can compare it back to this and go, oh, yeah, I'm good, it's in the ballpark, or oh, wait a minute, I must have done something wrong. So the first thing I'm going to ask you to do is turn all your mixed numbers into improper fractions. Right from the get-go, let's turn them into improper fractions. And if you remember how to do that, we multiply the whole number times the denominator, and then add the numerator. So I would do 2 times 3 plus 2. So 2 times 3 is 6, plus 2 is 8. So I have 8 over 3. And then this one, I would have 3 times 4 plus 1. So 3 times 4 is 12, plus 1 is 13. So now I have 13/4. Oops, that's a terrible multiplication sign. Make it a better dot. Okay, so I have 8/3 times 13/4. And if you're not remembering how to do this, change these from mixed numbers to improper fractions, that's something you should have learned last year. Come see me and I'll go over it with you in class. But for now, this is what we're doing here. 2 times 3, we do the whole number times the denominator, add the numerator, and then we put it over the original denominator. So 2 times 3 is 6, plus 2 is 8, so we have 8 over 3. And 3 times 4 is 12, plus 1 is 13 over 4. Now look at what this says here. Cross-reduce, question mark. And if you guys see a place where I could possibly cross-reduce in this multiplication problem? And some of you might go, oh, wait a minute, 3 and 13, no, those are both prime, and there's nothing I can do there, but how about 8 and 4? Well, yeah, I can divide them both by 4. So if I do 4 divided by 4, oh, I thought I'd change that to a different color. See if I can get a different color going here. So I do 4 divided by 4, I'm left with 1, right? And then 8 divided by 4, I'm left with 2. So now I have 2 times 13, which is 26, over 3 times 1, which is 3. Now, we don't want to leave this improper. Remember, we want to turn it back into a mixed number. So whichever way you're most comfortable with. How many times can 3 go into 26? Or if you want to say, well, I have 3/3 and 3/3 and 3/3 until you get there, that's fine with me. But we're going to go ahead and I'm going to say that I can put 8 3s into 26 and get 24. I had a brain fade there. So my whole number is going to be 8. And then I have 2 left over, so it should be 8 and 2/3 should be your answer. But see, check my math, because you know I'm not perfect. I sometimes make mistakes. So I get 8 and 2/3 on this one. So cross reduce if you can. I want you guys to start trying to do that. I know it's kind of new, and for some of you, you might like take to it like a duck to water. Others of you might be like, I don't know about that. But try to do that ahead of time. And then make sure that you're putting it from an improper fraction that's top heavy back into a mixed number. Okay? If you need to pause to finish writing that down, go ahead and do that. I'm right now before I hit the trash button, and then join me on the next slide when you're ready. Nope, come on. Oh, you know what? I'm going to go back one. And I don't know if I can bring that back. But our answer here, I want to say this. Our answer here was 8 and 2/3. Oops. Our answer here was 8 and 2/3. And I forgot something really important. And some of you guys were probably going, but Mrs. Elliott, why did we bother to estimate in the beginning? So we got an answer here of 8 and 2/3. And our estimated answer, remember, was 3 times 3, which was 9. Now when we go to check, 8 and 2/3 is really, it's in the ballpark of 9. And so we can say, you know what, this checks for reasonableness. It is a reasonable answer. It's close to what we expected to get. And so we're good there. So don't forget to do that like I did. This should really look more like a 2. It kind of looks like a 4, doesn't it? 2/3. I don't know if it made that better or worse. Okay, so moving on to the next one here. I think you've got some quick check coming up. Yep, quick check. So I find 10 1/4 times 2 3/4. Make sure that you're turning these to improper fractions first. It's vital that you do that. Turn them into improper fractions first, and then multiply top times top, bottom times bottom. If you're really struggling with that whole changing to improper fractions, come see me. I have a couple other ideas of ways that you can do this, kind of using the distributive property, which some of you like already. So come see me about that. But for now, I want you to try to turn them improper and then do that top times top, bottom times bottom. You can go ahead and hit pause, and then when you're finished, you can hit play and join me on the next slide. So here's an application problem. It says a student skis 3.5 miles in an hour. An instructor can ski 1 1/3 times as far in an hour. How far can the instructor ski? So we're looking here at first of all, let's figure out what information is important. So we have 3.5 miles in 1 hour, right? So definitely 3.5 miles is important. Now we'll come back and decide if this 1 hour is important for this part of the problem. But it says an instructor can ski 1 1/3 times as far in an hour. So we're comparing hours to hours, so we really don't need to worry about this hour piece right now. But this is important information. 1 1/3 times. So it says, how far does the instructor ski? So 1 1/3 times as much as the student. So we have 1 1/3 times as much as the student times the student equals the instructor. And we can write these equations because we just got done with that unit, right? So 1 1/3 times s. So we know the student is 3.5 miles in 1 hour. And that's going to give us how far the instructor skied. So the first thing we're going to do here is turn these improper. So I have 1 times 3 is 3 plus 1 is 4. So I have 4/3 times 3 times 2 is 6 plus 1 is 7 times 7/2. Now I'm going to look to cross reduce. This is something I want you guys to start learning to do. So I'm going to look for it right now. And I see when I come back over here that 3 and 7 can't do anything with those, but 4 and 2 I sure can. And so I'm going to divide by 2 here. That gives me 1. And I'm going to divide by 2 here, and that gives me 2. And then I'm going to multiply straight across. 2 times 7 is 14. 3 times 1 is 3. Now I'm not going to say she skis 14/3 of a mile in an hour. We're going to change that back into a mixed number. So we're going to change this back. You know, we can do it the way where we have, there's 3/3, that's 1, 3/3, that makes 6/3, 9/3 altogether, 12/3, and then I have 2/3 left over, right? So I have 1, 2, 3, 4 holes and 2/3 left over. And so 4 and 2/3, don't forget your units, miles. Okay? Now remember this problem for the next, we have a guided practice or a quick check problem that talks about the same thing, 3.5 miles in an hour. So keep that in mind. We're going to need that information for the next one. Okay? Oh, this is not the right slide. This is the right slide. So don't worry about that homework slide. That should have been deleted out. I thought I deleted that one out. That was from an old assignment. So this is the one I want you to do. Quick check. How many miles could the student in the previous example ski in 3/4 of an hour? So if we go back, 3.5 miles in 1 hour. So we have 3.5 miles. Oops. All kinds of technical difficulties, I guess. So I have 3.5 miles in 1 hour, and they want to know how far we could go in 3/4. So we want 3/4 of 3.5, and so we need to actually multiply 3/4. Right? We're looking for 3/4 of 3.5. So I'm going to have you guys figure that out before I do any more goofy doodles on the pad. Okay? So go ahead and figure that one out, bring it to class tomorrow, and we will see how you did on those quick check problems. So guys, just remember, fractions don't have to be scary. We can break them down into parts that we can understand, and if you're struggling at all, come talk to me and we will work through it together. We'll see you here. This next slide is our end slide. So today you should be ready to use multiplication to solve problems with fractions. When you come to class tomorrow, you need a complete set of notes, you need your quick check problems, and any questions you have for me. And we'll see you then.